Welcome to Miss Neville's lesson on an introduction to inequalities. Now, some of us started learning about inequalities last week before we got off on our nice long break. And some of us, this will be our first time with inequalities. This is a recorded lesson. So if at any time you need to pause the video to take notes or rewind the video to watch a different part again, please do so. There are going to be times where Miss Neville tells you to pause the video. At the top of your paper, could you please write inequalities? And we're going to start by talking about an inequality and what that would look like and what it actually means. To really understand an inequality, it's important for us to know wouldn't you agree with this? That 7 is less than 8? Remember, this is an inequality sign. You've seen these in 4th and 5th grade. And we read an inequality sign from left to right. So because this is going from left to right, this is the less than sign. This is our greater than sign. And of course, our equals to, it definitely just means equal, okay? Please pause this video now. So welcome back. Hopefully you wrote down our signs here. And we're moving right into what inequalities look like using a number line. If you'll remember in our study at the beginning of the school year, we started talking about inequalities and number lines. So I'm going to draw a horizontal number line. Okay, I'm going to have 0, 1, 2, 3. Could you draw this number line as well? As you were making this number line, we're then going to look to see what number is less than 5 on this number line. In other words, what inequality statements could I make using this number line? Could I say that 0 is less than 5? Yes, that's true. Could I say that 5 is greater than 3? Yes, that's true. We're going to continue to use a number line today as we start to solve inequalities. In your notes, let's go ahead and please write. I like using markers. There's so many colors I can use. Okay, solving inequalities. Solving inequalities. It's a little marker saying there. I want to think about a variable, an addition sign, and 5. And I want to say here, a number, remember a variable just represents a number we don't know yet. A number plus 5 is less than 10. Now, like with an inequality, we're going to solve it just like we would with an equation. We're going to isolate our variable or get our variable alone. And before we can do that, we've really got to understand what this is saying. So can you write a statement under here with Miss Neville? Some number, we don't know what yet, plus 5 is less than 10. So what could that number be? We have to understand that unlike an equation where we just have one answer to a problem, In inequality, we can have multiple answers. Star statement in our notes. Inequalities have lots of answers or solutions that would help to make their statement that this number sentence true. So to see what I mean by that, I'm going to first draw, and this time I'm going to use a vertical number line. I'll move the paper up in a second. Remember, because this is a recorded lesson, if at any time Miss Neville moves too fast for you, please pause or rewind the video so that you can keep up. I'm going to make a vertical number line here. Okay. I'm going to write our inequality over to the right side. 0, 1, 2, 3, 4, 5, 6, 7. And I'm just going to go all the way up to 7 there. Remember, the higher we go in the sky, the greater the value of our number goes. When we go below 0, we get into those negative integers. So to solve this, we're going to isolate our variable. The opposite of addition, or our inverse operation here, can you tell me? Very good. Subtraction. Because I'm adding 5 to our variable here, I'm going to subtract 5. So now we've canceled out our 5s. Whatever I do to the left side of a problem, I also want to do to the right side. And we know now our x is alone. We still have our inequality sign. And 10 minus 5 is 5. So what does this answer tell us? This tells us that x can be any number that is less than 5. Doesn't that give us a lot of solutions? Absolutely. X can be any number that is less than 5. Let's write that down. So, on my number line here, I'm going to find 5, and I'm going to make an open dot. Okay? Because here, we're going to be able to show which numbers, which answers or solutions could make this statement true. Now, is 5 less than 5? Did you say no? You're correct. 5 is not less than 5. 5 is equal to itself. So, if x is less than 5, x could be any number. I'm going to shade down our number line here. It could be any number that is less than 5. So, could x be 4? You'd better believe it. Could x be 2? Yep. As long as that number is less than 5, our x could be there. Now, let's make sure we're understanding what we've actually done here, okay? Let's make sure we're understanding what we're actually have done here. When we see this, we see I can substitute any of these numbers for the x here, and I'll make my number sentence true here. So I'm going to substitute that x from our original answer with a 4. And you know 4 plus 5 is, yes, It's 9. And isn't 9 less than 10? Yep. So it makes that number sentence true. Let's do another example. Example 2. Example 2. Use my favorite color this time. Okay. Let's make it a little bit tougher. Are you ready? 3x is less than 17. 3x is less than 17. Remember, with our units, we can now use our calculators. So, I'm going to have my calculator out here, my handy dandy calculator. And you want to remind yourself, whenever I see a coefficient or number beside our variable, am I adding, subtracting, multiplying, or dividing? Did you say multiplying? You're correct. So if 3 is being multiplied by x, some number, how would I get the 3 away from the x? Or how would I isolate this variable? Well, I would divide by 3. So now our 3's have canceled each other out. We have our x here. We have our less than sign here. And whatever we do on the left side of this inequality, we must do on the right side as well. And I'm going to use my calculator, and of course it went to sleep. I'm going to use my calculator here to divide 17 by 3. And my answer, remember we round to the nearest hundredth, my answer is 5.67. X can be any number that is less than 5.67. So, could X be 5.5? Well, is 5.5 less than 5.67? You'd better believe it. Could X be 16.5? Well, is 16.5 less than 5.67? No, it's greater than. So, that solution won't work. Okay? What we're going to be working on today, are some practice assignments where you're going to be able to start flexing your muscles on solving inequalities. I look forward to seeing everyone on Wednesday. Please get to work in your new Schoology folder. You may use your calculator. Then you are to complete 2 Math Nation lessons on your ramp. Please use notebook paper to show your work. Bye.